Welcome to Unit 3, Trigonometry. This is Section 1 on the unit circle, which is in Chapter 4 of your pre-calculus textbook. At the outcome of this chapter, you should be able to develop trigonometric reasoning. To do so, you will have to develop an understanding of angles and standard position expressed in both degrees and radians. Develop and apply the equation of the unit circle, and solve problems using the 6 trig ratios for angles expressed in radians and degrees. You've had some experience with trigonometry in previous grades, such as grade 8 when you talked about the Pythagorean theorem, and then grade 10 in Math 10C, you did the primary trig ratios. These are both only applicable to right triangles, so in Math 20 you use the sine and cosine laws for non-right triangles. You're going to continue to build on trigonometry learned in previous courses in this one here. To complete this section, you have a bunch of things you got to do. So one of those is a trigonometry pre-assessment. If you haven't done that, then you should probably pause this video, get that out, and get it sorted out before you continue. Your teacher will have the key for this, so make sure you ask it for it when you are done your pre-assessment. After that, you can turn this back on and start into part 1, angles and angle measure, notes and practice. So there'll be a whole bunch of notes and some video instruction, and then there's some textbook practice questions at the end of each part that you're expected to do and show your teacher upon completion. We then now have part 2, the unit circle, part 3, trig ratios, and part 4, introduction to trig equations. When those are complete, then there's a unit circle review, which is a formative assessment, so it doesn't count for marks. But there are 2 summative assessments. Your teacher may choose to do both, or may just choose one or the other. So it is possible, though, to do a curriculum review and a unit circle quiz. Okay, so back in the days when trig was, really easy, here was SOHCAHTOA. We're going to move on to something a little more complex. So hold on, this stuff gets good. Okay, part 1, angles and angle measure. First thing you need to do is learn what an angle in standard position looks like. Angles are made up of 2 arms. One's the initial arm and the other's the terminal arm. The initial arm is found on the positive x-axis, okay? And the terminal arm can be found in any other quadrant. The angle is always measured from the initial arm to the terminal arm. In order for it to be considered in standard position, the vertex of the angle must land on the origin of the coordinate plane, okay? So at 0, 0. All right, there's 2 ways we can measure this angle. As seen in this diagram, going from the initial arm to the terminal arm in a counterclockwise direction produces a positive angle. And of course, going the other way, if we were to take from the initial arm to the terminal arm the other direction around the circle, which is clockwise, that produces a negative angle. Now, you can go around the circle as many times as you want. One complete circle has a measure of 360 degrees. So to make 500 degrees, we have to go around the circle 1 full time and another 140 degrees. Because the 500 and the 140 share the same terminal arm, they are called coterminal angles. Are there other ones coterminal with 500? Of course there are. There are infinite numbers because we can go around the circle both clockwise and counterclockwise an infinite number of times. So we're going to draw a couple of angles in standard position, one positive and one negative, coterminal to 500. Okay, so let's draw in our crosshairs, and then I'm going to change the pen color. So there is my initial arm, and my terminal arm will go over here in quadrant 2. And if I go from here to here, I know that's 140 degrees, and that's positive because it's counterclockwise. So to go, if we go clockwise, to make that full circle, I know this guy is going to be a negative angle, but how much does it measure? Well, if a full circle is 360 degrees, then if I were to go 140 degrees, take away 360 degrees, I would get negative 220 degrees, and that would be coterminal with 500 and coterminal with 140. To pick up another positive one, there's our crosshairs. Okay, our initial arm again on the positive x-axis, and our terminal arm in quadrant 2. So, one that would be coterminal with 500 but positive, well, instead of subtracting 360, I can add it. So that gives me 860 degrees. Now, 500 was one full rotation around, and then a little bit more. So to go another 360 is another rotation, and a little bit more. So that measures positive 860 degrees. Okay, and again, you can keep going around and around the circle as many times as you like. Each time you get to the terminal arm, that produces another coterminal angle. Okay, next page. All right, radian measure. Up until now, angles have only been measured in degrees. Other units that angles can be measured in are radians, gradients, and revolutions. The unit depends on the situation. In Math 30-1, radians will be used in addition to 2 degrees. So, what is a radian? What you need to do is pause the video and go find yourself a piece of string or some thread and turn it back on and use the following circle for the demonstration. Okay, so if you have your piece of string, I would like you to put one end here at the origin and the other end here, and then I want you to cut your string, or at least make sure that you have a way of making a specific measurement. Okay, so your string should be lying right along here. Okay, what's that distance called? You should remember from junior high that that is a radius. Okay, now what I want you to do with your radius, your piece of string that you've cut to this length, I want you to take it and I want you to put it around the edge of the circle so it goes on just like this, okay? And I want you to mark off where the other end is, and then I want you to connect those points there, okay? The angle formed here at the origin, known as the central angle, that angle is 1 radian. Okay, so radian is the measure of the central angle that is bounded on all 3 sides by a length equivalent to the radius. As seen in the demonstration, well, let's continue. If you were to take and put as many as you could in the first half of the circle, so there's one, and there's another piece of string, there, and there's your third one. So, to get to, if this is 0 degrees, to get over here to 180 degrees, I have 1, 2, 3 pieces of string and a little tiny bit left over. 3 and a bit. 3.14. That should remind you of something. Oh, right. That's pi. So as seen in the demonstration, 180 degrees is equal to pi radians, meaning that 360 degrees, so if I were to go a full circle all the way around back to the start, if 180 is the same as pi, then 360 would have to be 2 pi. The relationship can be used to convert any angle from degrees into radians and vice versa. So all you'd have to worry about here is cross multiplying. Radians are not written with a unit symbol. For example, 2 pi does not have radians after it, like 360 has a degree symbol. Okay, so let's do a couple of examples. If you're given a question in degrees, convert it into radians. If you're given radians, convert it into degrees. Okay, so we're given degrees, 90 degrees. So we're going to start with the fact that pi is the same as 180. And when we do proportions, we should always put the same things on the same level. So because 90 is a degree, we put it with 180, and now we're going to cross multiply. So 90 times pi divided by 180 is x. So that would be 90 pi over 180. 90 divided by 80 is 1/2. So 90 degrees is the same as pi over 2 radians. 152 degrees. Again, we're going to start with pi is 180. And x over, again, 152 because degrees go with degrees. So x is going to equal 152 pi over 180. And we can reduce that to 38 pi over 45. Next one, C, we're given pi over 4 because it's got a pi in it and no units. We know it's in radians. So we know that 180 degrees is the same as pi. So pi over 4 is how many degrees? Okay, so again, cross multiplying. 180 times pi over 4 divided by pi gives me x equals 180 times pi over 4 divided by pi. The pi's cancel, 4 goes into 180, 45 degrees. 9.25 also is in radians because we know that it has no units. So 180 over pi is equal to 9.25 x over 9.25. So cross multiplying gives us x is equal to 530 degrees approximately. Okay? Why approximately? Well, if you remember, pi is an irrational number. So if you can't cancel out the pi, then you're going to get an answer that's not exact. So therefore, we have approximately 530 degrees. Okay, negative 480 is in radians, or in degrees, sorry. So we're going to change it into radians. So pi over 180 is equal to negative 480 under x. So again, cross multiplying, x gives us negative 8 pi over 3 in lowest terms. You can always use your math frac button on your calculator to help you figure out the lowest terms. Just don't type in the pi. Just go 480 divided by 180 and then change that into a fraction and put a pi at the end of it. Okay, and last but not least, we have negative 25 pi over 6. So again, we're changing that into degrees. So 180 over pi equals negative 25 pi over 6. And that's x equals. Okay, so cross multiplying 180 by negative 25 pi over 6, and then divide that by pi, and you get negative 750 degrees, which is exact because we can cancel out the pi's. Okay, next page. Arc length. An arc is a portion of the circumference. To find the circumference of a circle, use the formula c equals 2 pi r. Notice that the formula contains 2 pi, so when the arc is the circumference, it is created by a full rotation of the terminal arm. Therefore, to determine the length of the arc created between the ends of the initial and terminal arms, the formula A equals r theta is used, where A is arc length, r is the radius of the circle, and theta is the angle in standard position given in radians. So please don't use degrees when you use this formula. You may be asked to have an answer that's in degrees, but find it in radians first and then convert it into degrees. All right, how did we get that formula? Well, remember, if we have a circle, okay, then there's my initial arm. Let's say that's my terminal arm, and there's my angle theta, okay? So, theta is a portion of 2 pi, because 2 pi, again, it would be the entire rotation, okay? Then, the arc created by angle theta would be proportional to the circumference of the circle, because it's a portion of the circumference, okay? So that means that theta over 2 pi equals A over circumference, again, is 2 pi r, so I'm going to substitute that in. Well, if you notice then, the 2 pi's can both be canceled out, and we get theta equals A over r, or A, whoops, try that again, A equals r theta. Okay, let's use that formula to do the next couple of examples. And then you're off to do some practice on what you've just learned. Determine the length of an arc of a circle where the radius is 15 centimeters and the central angle is 5.5 radians. So r equals 15 centimeters and theta equals 5.5 radians, which is good because that's what we need for our formula. So A equals r theta equals 15 centimeters times 5.5, which gives us 82.5 centimeters. Notice that the arc length and the radius are measured in the same units. All right, next example. Given that the arc length is 19 millimeters for a radius of 23 millimeters, what is the measure of the central angle to the nearest tenth of a degree? So this one wants us to find it in degrees. So first we have to find the angle in radians and then convert into degrees like we were doing on the last page. Okay, so we have arc length is equal to 19 millimeters. And we know the radius is equal to 23 millimeters. So the first thing we're going to do is use our formula. A equals r theta, but we're going to rearrange it to find theta. So A equals r theta. So to get theta by itself, we're going to divide both sides by r. So theta equals A over r. So that's 19 millimeters divided by 23, which gives us approximately 0.2826 radians. To convert that to degrees, we use the ratio that pi is equal to 180. So put the radians on the same section, on the same level, and again cross multiply. So 180 times 0.826 divided by pi. Again, remember, if 0.826 is not an exact value, please use the exact value on your calculator. Okay, and that gives us 47.3 degrees to the nearest tenth. All right, all done this part of this work or instructions. So practice on page 175, questions 1 to 9, you get to choose 2 questions from each part. So question number 1, choose A and D, for example. Question number 2, choose B and C, and so on and so forth. Okay? And then you got a few other questions to take care of, and then show your teacher so that they know that you have completed this work and are ready to move on to the next part.